Continuing on with our exploration of an exponential function, f of x equals a times b to the x, let's examine what happens when we let x be 0. So if x is 0, let's find f of 0. So f of x is equal to ab to the x. So f of 0, f of 0 is equal to a times b to the 0. But remember, we learned in section 4.1 that b to the 0 is equal to 1. So this is really a times 1, which is a. And thus we've learned something kind of interesting, which is that f of 0 is equal to a. Now what does that mean? Well, that means that when I put 0 into this function, I'm always getting the letter a out, the one that's in front. And so that means that 0 comma a is always the y-intercept of the graph, because if your x value is 0, you're talking about the y-intercept. So let's look at a couple examples. So if I have g of x is equal to 5 times 3 to the x, then the y-intercept would be 0 comma 5, because I can see that there's a 5 in the front of that problem. All right, what about f of x equals 2 to the x, which we graphed actually a little bit ago? Well, 2 to the x, let me put it over here so you can see it. 2 to the x, you don't see a number there in front, so that means it's 1. And if you look back at our graphs from a couple pages ago, right here, 0, 1, see it right there? When you crossed the y-axis, when x was equal to 0, that was 0, 1, so 1 was your y-intercept. Okay? So we're already seeing this, we just didn't realize it. 0 comma a is the y-intercept. All right, now how does b do to the graph? So we were seeing how the base changes things. We already filled in this table a little bit ago, and then we could see this table from a little bit ago. So what's happening here? If I think it's easier to see with the whole number parts. If I take 1 and I multiply it by my base 2, I get 2. Then I take 2 and I multiply it by my base 2 and I get 4. And 4 multiplied by my base 2 gets me 8, and so on. So as I work down, as every time my x goes up by 1 here, my y is getting multiplied by 2. All right, what about over here? Every time your x goes up by 1 over here, then your y is getting multiplied by, well, it's not a whole number, because if it was a whole number, it'd be making it bigger, right? So you're multiplying by something that's a fraction. Well, how about a third? Right, 27 times a third would get you 9. 9 times a third gets you 3. 3 times a third is 1. 1 times a third is a third. A third times a third is a ninth, and so on. So we're learning this very important property. Let me type it up. Just one sec. There, I made a picture of it instead. It was easier to do it that way. So let me just show you here. Every time we add 1 for my x, right, going up by 1, going up by 1, going up by 1, I multiply by 2, multiply by 2, multiply by 2. So that's what my base is. For this one, every time we go up by 1 each time, then we're multiplying by a third. 27 times a third, 9 times a third. And a lot of students see the division. They say 27 divided by 3. Well, but division by 3 is multiplying by a third. Think about it. If you take a loaf of bread and you divide it into 3, what have you done? You've cut it into 1/3, right? See? Okay. So it all works out. All right, in the table of values for an exponential function, if the x values increase by a constant amount, right, that's the x going up by 1, x going up by 1, right, that's the constant amount, then the y values are related by a constant multiplier. This is very different from what we had in the first 3 chapters. When you're dealing with lines, they add the same amount every time. But here we're multiplying by the same amount every time. So that's what makes an exponential an exponential. So in other words, for an exponential function, f of x equals a times b to the x. If the x values increase by 1, then the y values are multiplied by the base, b. Now remember, from earlier, from your first exam, chapters 1, 2, and 3, for a linear function, if the x values increase by 1, then the y values are, well, it's added or subtracted, right? Because they kind of go hand in hand. Subtracted by the slope which is m. Okay, so two very different functions, but you have to know them both really well. Exponential functions get multiplied, which could mean they're growing or shrinking if it's multiplying by a fraction. Linear functions either get added, which makes them grow larger, or subtracted, but it's a constant amount every time that they're adding or subtracting. Whereas exponential functions, it's a constant amount that you're multiplying by. All right, so now that we know this, we know that a is the y-intercept right here, right? And we know that b is our constant multiplier. We'll be able to use that to answer some questions. So start with this one. We want the y-intercept of the following equations. What are they? Okay, well, remember that the y-intercept is 0, comma, a. So you just have to look at it and think a times b to the x. So a for this problem is 8. All right, what about the next problem? Let's see, it's 0, comma, negative 13. Because when you look at the front of that problem, negative 13 is your a. All right, now the hardest one to see is actually this last one. So you don't see a number in front of the 3. So really h of x, hold on, h of, there we go, x is equal to 1 times 3 to the x. So that means the y-intercept is 0, comma, 1. All right, now we have to determine whether or not the following functions represent a linear or an exponential function. Okay, so remember, we're looking for a whole bunch of things. We're looking for constant increases in our x, and then for linear ones, we'll have a constant increase, i.e. a slope, and for exponential ones, we'll be multiplying by something. All right, so let's look here. This first one, let's see. X is going 1, 2, 3, 4, constant. That's good. Now, are we multiplying by something every time to get this next problem? So that's what we need to think about. There, wanted to make some space to write an answer here. All right, so let's think. What could we multiply by to get from 360 to 180? Or from 180 to 90? Or from 90 to 45? Honestly, I think with these smaller numbers, it's a little bit easier to spot. But if you could multiply, well, think about it this way. If you divide by 2, you'd work your way down, right? 360 divided by 2 is 180. 180 divided by 2 is 90. 90 divided by 2 is 45, and so on. So h of x is equal to, now, we need to look for our y-intercept because it's a, b to the x. This is going to be exponential. So what's our y-intercept? Well, the y-intercept is right here. It's 0, 360. So there's a right there. A is 360. B, well, we're dividing by 2 to work our way down the table. So that means we're multiplying by a half. Right? Multiplying by a half is the equivalent of dividing by 2. Oh, and I should have said it, but this is obviously exponential, right? All right, now let's move on to the next one. Consistent x's, that's good. Let's look at the y's. Let's see. Subtract 6, subtract 4. No, subtract 6, yeah, 4. Subtract 8, subtract 6 again. Well, that's not good. So that's not linear. What about exponential? Well, let's grab a calculator. Let's see, quit. If I take 38 and divide it by 32, I get 1.1875. 32 divided by 28, not the same thing. All right, I'm done. So this isn't consistent. It's not working its way down consistently. So this is neither. The y's were inconsistent. Right? It wasn't adding the same amount every time, and it wasn't multiplying by the same amount every time. All right, let's move on to the next one. 10, 20, 30, 40, that's consistent. It's not 1, 2, 3, 4, but it's consistent. Let's see. 7 times 2 would get you 14. Times 2 would not get you 21, so that's no good. Let's try adding. 7 plus 7 gets you 14. 14 plus 7 gets 21. 21 plus 7, that works. Okay, so this is linear. Right, we're adding the same amount every time. We just got to figure out what it is. So j of x is equal to, now remember, linear is mx plus b. Okay, so b is your y-intercept there. So look at your table and you can see the y-intercepts right here. Matter of fact, I'll highlight the y-intercepts for you guys. Let me do a bucket. Hold There we go. So let's see. We know it's 7. Now we just got to figure out the slope. What are we adding every time to work our way down the table? Well, that's 7 too, actually, because 7 plus 7 is 14. 14 plus 7 is 21, and so on. So there we go. All right, so now let's look at this last one. So this one was a neither. That was exponential on the first one, linear on the third one. 5, 15, 20. Uh-oh, we're in trouble. We're going up by 5. We're going up by 10. We're going up by 5. We're going up by 10. This is neither, because our x's are inconsistent. If I could spell the word inconsistent. All right. There we go. Okay, so we're all done with that particular problem. All right, and let's look here. Now here, I've given you some exponential functions. These are the numbers that fill them out. So we're going to have to figure out the rest of the table and then find the equation for it. So there's a lot of different ways to do this, but with our skills at this point, what we can try is just trial and error. We know these are exponential, so we know we're multiplying. So let's just try multiplying. 2 times 2 is 4. Times 2 would be 8. Times 2 would be 16. Okay, that's no good. I want 54. So let's clear that out and try again. 2 times 3 gets 6. Times 3 would be 18. Times 3 again would be 54. There it is. And then the last one would be 162. Okay, so 6, 18, 54, and what was the last one? 100 and something? 162. Okay, so now that I've got those ones filled out, I can see the y-intercept. Let me highlight it again right there. Okay, so I know that I'm working with an exponential function. So it's going to be h of x equals a times b to the x. All right, a is the y-intercept for an exponential function. So in my case, it's 18. Done. And then b is what we're multiplying by. So as we worked our way down the table, we were multiplying by 3. 2 times 3 made 6. 6 times 3 makes 18, and so on. So there we go. Done with that. All right, now what about over here? Oh, okay, let's think about this as division, and then we'll flip it to a fraction when we're done with it. So let me move this over here. Oops. Why does it do that? It's annoying. All right, so 729 divided by 3, let's just try 3, divided by 3 gets you 81, 27, there it is. That's the one. So let me fill those numbers in. Okay, there they are. And so now I need an equation. Well, look, there's the y-intercept again, 0, 81. So I know it's going to be k of x equals 81. We were dividing by 3, so that means we're going to be multiplying by a third. We were dividing by 3. Let me say it again. We were dividing by 3, so that's the same thing as multiplying by a third. If I take 729 and times it by a third, 1 over 3, I would get 243, right? So there's my base. It's 1/3. All right, that's the end of that page, and I'll see you back here for the next page.